Hello, everyone. This is Jon Cortez from Neudesic. I'm the National Solutions Director for Mobility. My primary main focus is mobility across Neudesic.
Great, John. And I'm Zack Ciesinski. I'm a partner manager here at Xamarin, and I help support Neudesic and all their mobile efforts.
All right, so let me start with giving you talk briefly about Neudesic. So Neudesic is a premier technology firm who specializes in IT services such as app dev, UX, BI, systems integration, collaboration, and managed services. We have partnered with Xamarin to provide our customers with the best-in-class mobile solutions.
Thanks, John. And then here at Xamarin, our goal is to delight developers. So using our platform, you can build and develop completely native and also cross-platform mobile applications across iOS, Android, and Windows entirely in C#. But before we get started, we thought we'd take a quick poll and just hear how you guys today are building your mobile apps. So you should be seeing a poll on your screen. I think Kristen's going to launch that, and it'd be great to see what you guys are doing today. So we'll give this maybe 30 seconds, 45 seconds, and show the results. All right. So it looks like most of you are doing native app development today, some web apps, some hybrid apps. All right, so we got a full spectrum. Some of you are not doing any app development at all, or mobile app development, and some of you are unsure. So that's actually a great response, and this can kick us off into sort of the approaches of mobile application development. So prior to Xamarin, there were really two main approaches to take that are still approaches today, as we just saw. The first being the siloed approach. So this is building an application 3 separate times across your 3 platforms. So you're using Xcode and Objective-C for iOS, you're using Visual Studio and C# for Windows Phone, and you're using Eclipse and Java for Android. Now, this is great because you are giving your users that native experience that we've all come to expect and love with our mobile phones. However, this is very expensive to not only staff, but also maintain, because you will need 3 separate mobile teams in order to build these 3 separate mobile applications, and you cannot share or reuse any code across these 3 platforms. As you see, you have 3 different languages, Objective-C, C# and Java, that you're using. So what happens if, say, your Objective-C developer or team lead decides to leave the company or gets sick for a few weeks, has an emergency? You end up putting those projects on delay, which slows innovation as well, which means you can't really keep consistent release schedules or release cycles with your mobile applications. However, you are giving your users that native look and feel, native user interface that they're so used to, that they love. The alternative to this approach is the hybrid approach. Now, the hybrid approach was pretty popular a few years ago, right when mobile was coming on the scene, because essentially it allowed you to take your familiar languages, your JavaScript, your HTML, your CSS, throw that all into this box, and out would come 3 mobile applications cross-platform. That's why the term cross-platform is almost a dirty word in the industry nowadays, because hybrid approach, generally speaking, leads to an incomplete API coverage, slow performance, which causes high abandonment rates across your employees or your consumers who are using those applications on a daily basis. And I think this really came to fruition a few years ago when Mark Zuckerberg over at Facebook came out in 2012 and said, we relied too heavily on HTML5 as opposed to going purely native. So back in 2012, their stock price was in the low teens. Their app ratings on the App Store were 1 star, I believe, on the iOS side, and 1.5 star on the Google Play side. So really not a great user experience, and their users were hating using the mobile application. Fast forward to 3 years later, they're doing the siloed approach, taking that pure native approach. App ratings are now 4, 4.5 stars in those stores, and their stock price is up to $70, $80 a share. So these are still two approaches to take to mobile development, but what's great and very unique about Xamarin is that we're uniquely positioned in the market, allowing you to develop completely native, but also cross-platform mobile applications entirely in C#. So you'll see here, you can share anywhere from 60 to 100% of your code base, depending on the application that you're looking to build. Our customers on average are reporting 75% code base reuse, which is all your back-end business logic that you're using and reusing. And then on the front end, you're still using C# to customize the UI across iOS, Windows Phone, and Android. However, you only need one mobile team now in order to do that, as opposed to having 3 separate mobile teams working off 3 separate code bases. So this is a much more efficient approach to take, and we still give you that native API access, native user interface, and native performance, so that your applications are actually truly native as opposed to these hybrid applications that may lack in performance. Now, this probably seems a little too good to be true, and slides are great, but I actually wanted to turn it over to Jon Cortez, who's built plenty of applications using Xamarin. He's going to walk us through a few more slides and then actually get into a demonstration of how to use Xamarin.
Thanks, Zach. So I would like to share first a statistics regarding an application called iCircuit that was featured in the App Store. So iCircuit is a real-time circuit simulator and editor used to design analog and digital circuits. It was developed by Frank Kruger, and using Xamarin and Nougat third-party libraries, he was able to realize up to 90% code reuse across multiple platforms. And this is an amazing amount of code reuse across the different platforms by just leveraging C#, Xamarin, and Nougat libraries. When using Xamarin, there are 2 main options for sharing code across platforms. The first one is portable class libraries, or PCL. With a PCL project, you can write all of your C# code in one assembly and share across all platforms. This is made possible by only supporting a subset of the .NET-based class libraries that are also supported in your target platforms. When you create a PCL project, you will be asked which target frameworks you would like to support. The downside of going with this option is that you cannot write platform-specific code in the PCL library. However, you can still use interfaces and dependency injection to provide platform-specific functionality. The second option is to make use of shared projects. With a shared project, you can also share code across multiple platforms or multiple projects. Shared code can be branched based on the platform using compiler directives. In your shared code, you can include platform-specific references, such as, for example, UI label for iOS, and then text view for example, for Android, and they are conditionally compiled using compiler directives. Both PCL and shared projects are effective options for code sharing. A lot of the developers I know prefer PCL over shared projects. The reason is because with shared projects, you could potentially have a lot of those conditional compilations in your code, which can get a little bit confusing, harder to maintain, versus having only cross-platform code that works on your PCL library. However, there are also developers that I know that have used both and have incorporated both PCL and shared projects in their solution. Nougat is the most popular package manager for .NET development. It is the best code is pretty much the code that you do not have to write and maintain. So leveraging as much as third-party libraries that works for you is the best way to go. Nougat is built in Xamarin Studio, which is, I'm going to talk a little bit more later, which is an IDE that is by Xamarin, and then also Visual Studio, which allows you to easily search for third-party libraries and add them to your projects. The apps that you build using Xamarin are compiled down to the APK or IPA binaries, which means that you can be able to distribute these apps just about anywhere and any store. You can also distribute it internally using third-party services such as TestFlight, Hockey App, and even your enterprise app store. There are two choices when developing for Xamarin in terms of integrated development environment or IDEs. The first one is Xamarin Studio. This is Xamarin's own IDE, which runs on both the PC and the Mac. It is feature-rich and includes everything that you expect from a best-in-class development environment. You have code completion, UI designers, integrated debugger, and deployment tools. The Xamarin plugin for Visual Studio allows you to develop native iOS and Android apps on Windows where you can take advantage of features such as IntelliSense, UI designers, integrated debugger, integration with tools like ReSharper, TFS, Jenkins, TeamCity, and your favorite code coverage and profiling tools. With Xamarin iOS for Visual Studio, it will allow you to develop native iOS apps on Windows with a paired Mac, providing build services over the network. So Xamarin Designer for iOS is the first iOS designer available in Xamarin Studio and Visual Studio. So inside of the IDE, you can be able to go and create your UI using just drag and drop paradigm. You can be able to go set the properties of these different UI controls using the property window. So everything that's familiar to a .NET developer, you can be able to, it is already supported in Xamarin Designer for iOS. Xamarin also provides the Android Designer, which is also available in both Xamarin Studio and Visual Studio. Again, you can be able to use drag and drop to create your UI, and it can be able to target multiple screen sizes, resolutions, and Android versions. All the layouts that you create are saved in standard Android XML files, which is portable in terms of being able to go and use that in Eclipse and also in Android Studio. There are 2.5 billion devices in the market today, and you have multiple platforms: iOS, Android, Windows. You got Windows Phone. You also have Mac. And being able to go and do code sharing across all those platforms using Objective-C, Java, and C# alone, there's not going to be a lot of reuse in there because of the differences in languages, the availability of those third-party libraries you want to use. Those are pretty much the obstacles you are going to encounter when you're developing in this the siloed approach, as Zach mentioned earlier. Now, C# is the bridge that makes things possible in terms of cross-platform. So C# is shorter, simpler, and more maintainable, and it supports the new language features in C#, like, for example, LINQ, Lambda expressions, you got events, you got generics support, you got async and await for asynchronous operations. So my personal favorite in terms of the language of programming language is C# because of just the elegance, but at the same time it's also key to the cross-platform story that Microsoft and Xamarin has for mobile development. So using C#, you can write all of your code for mobile development and share that across different platforms such as iOS, Android, Windows, and the Mac. All right, so let's go and switch gears and do a quick demo. Let me set up first the context of the demo. So the scenario is that a team of 2 developers were asked to go and develop a contact list application, one in iOS and one in Android. So what they did is to go and create that in Xamarin. However, there's no code sharing across those 2 platforms. So we will go ahead and inspect that code first, that the projects, and then we will refactor that to make use of a cloud service, and at the same time do some code sharing using a PCL class library. We start off in a second. Start off Visual Studio here. All right. I hope you can see this clearly. All right. So in this project, in this solution, it's called My Contacts. There's two projects. You got the iOS project and you got the Android project here. And right now, let me just go run this real quick. I'm going to go run it in iOS. Okay. All right, here you go. So as you can see, it's just a contact list where you can go and click on each of the contact, and it will go and navigate to the details page for that contact. Then let me go also run the one for Android. Click. Oh, that one. Okay. So same thing. You can go and be able to scroll through this list and be able to go and navigate to a page or a screen that displays the details about the contact. So let's take a closer look at the application or the source code here. In iOS, you have, and this is that applies for both projects. There is a model class which pretty much models what the information that it is consuming, right? So it has a contact, it has a name, a headshot URL for the image, and then also the email address. Now also in here there is a service class that is called contact service. So it's using an interface called iContact service, and there's only one method there right now, which is get all contacts. So this particular class called contact service is implementing that class, that interface, and it's making use of a class called Simpson Factory, which pretty much goes creates an in-memory list of contacts right now. So this is something that we will be refactoring to go and make use of a cloud service that serves the same information, and then we will be able to go and do some more code reuse. As you can see, all of this code is duplicated on the Android as well. So you have the model class here as well. You have the services classes here, and then of course you have all the UI code that goes and render all this information on the different screens. Okay. So let me go and close this Windows real quick. And let me launch a. So this is the Azure Web API service that we will be using to go and retrieve the data. So right now it's hosted in Azure as an Azure website, and it's just serving up JSON here, which is a list of the contacts that we are going to use for the application. I have also embedded some of the images that for the headshot images in the application. As you can see in iOS, you can see that under images, and then in Android you can see that under drawable. So all of those images are going to be under that. All right, so let's start with pretty much doing a creating a PCL library here. Let's go add new project, and let's go pick class library portable, and we're gonna call it mycontacts.core. It's gonna ask us what are the target frameworks, and we're just gonna click on OK to accept the default choices. We're going to go and remove class1.cs since we don't need that one. Okay. So again, the goal here is to refactor the solution so that we don't have redundant code, and we're just going to go and put all that redundant code into a single PCL class library that the two projects will be referencing, so that we can be able to go and do code reuse. So let me go and set up the references here. So I'm on the Droid project. I'm going to go and add a reference to the core or the PCL project. So that's already there. Same thing here. All right. Now we're going to pull in some. We're going to pull in some Nougat packages here for the PCL library, since we need to go and access an Azure web service. So we need to pull in some packages. Just sometimes Nougat can be slow. So what we need to pull in here is JSON.NET. We also need to pull in the Microsoft HTTP libraries here. Okay, so let's go pull in JSON here. You would actually pull in this Nougat packages for all three projects, but since those three Nougat packages are, because those Nougat packages are already exist on Droid and iOS when I pre-built these applications, we don't need to pull that for those two projects anymore. Okay, so the next one is the Microsoft.NET HTTP client libraries. Okay, so we're done adding those Nougat packages. As you can see, it's now referencing Newtonsoft.json and then also system.net HTTP. All right, so the next step here is really to go and move the model folder from, let me set this first as a starter project. We're going to go and move this redundant code into the PCL and adjust the namespaces, and then refactor that so that you will use Azure. So let me move that model class, just that one to core. Okay, close this. Then we're going to remove that from this project. Same thing with the one in Android. Delete. All right, the next one is we're going to move the services folder into the PCL. Hang on a second. My mouse is not cooperating right now. There you go. All right, so here we have a contact service. We're gonna need to adjust the namespaces here. We could have used some refactoring tool here, but it's just gonna be just easier because there's not a lot of files. Just close this down. Oh. Okay, then the Simpson factory, which is the in-memory list of contact information, we don't need that since we're gonna get that information from the Azure web service. So we're going to go delete that. I'm going to delete this code here. For now, we're going to go and plug in our code here to go and retrieve the data from Azure. So we're going to go and delete those files or folders in the platform-specific projects, since we don't need them anymore. All right. So now we now need to go and implement the iContact service in this particular class. So let me just get that data here. Here you go. Okay. Okay, so let me just explain this code real quick. So we have the URL to the Azure service. It's a web API service that serves up JSON, and then we're doing some caching here so that once we retrieve the list of contacts, we're just going to go cache that for the lifetime of the application. There are other ways to do caching. We're just doing a very simple one here, and at the same time, there's also ways to go and refresh the cache whenever you need to go and refresh the data on the mobile device. So in this case, we're just checking if contacts, which is a list of contacts, is null, and then if it's null, then we go and instantiate a new HTTP client. We're going to go and call getString async on the HTTP client class, and then pass in the service URL. We will be getting a JSON string here, and then using JSON.NET, we are now going to go and deserialize the JSON string into a list of contact objects, and then we are going to go and return that list of contact objects. Okay. So that is contact service. Now we need to go adjust some of our references on those platform-specific projects, since they're still referencing the services and the models that were created on those projects. So let me go start first with iOS. So in iOS, I'm going to go make those adjustments again. Core. Okay, so that's good. Okay, so that's we're done with iOS. Now we're going to do Android real quick. Should not be too much here. So what's happening now is that we're just saying, hey, I'm going to go reference the model class and the services class that we have moved to the PCL. All right, that's it. Okay, now let me show you real quick what the UI looks like in terms of the designers. So if I go to iOS and open up the storyboard, I want to go show the iOS designer here. So the iOS designer right now supports storyboard files. This is something that you can be able to also open using Xcode in a Mac, and pretty much they are compatible with each other. You can be able to go and edit your storyboard either in Visual Studio or Xamarin Studio. So in this case, we have two main screens, which is the first one is the list of contacts, which is the table view controller, and then it has a custom cell where it has an image and a label for the name, and then a label for a smaller label for the email address. So this is a custom cell that you define, and if you look at the properties here, let me open up the properties window, you can see that this particular view controller is actually is mapped to a class called contacts view controller, which is here. And then this custom cell, let me select the custom cell here. There you go. This custom cell is mapped to a class called contact cell view that we create, and it derives from, if you open contact cell view, contact cell view derives from a UI table view cell. Okay, so these are all iOS specific classes, and the next piece here is this screen, which is the contact details. So contact details is just a UI web view, sorry, a UI view that has 3 elements: an image, and then a couple of labels here for the name and also for the email. The way you navigate from the list to the detail is through a segue. So this, if you click on this segue, I have marked it with an identifier called contact segue. So the way this works is that if you open up the view controller that contains the list of contacts, it goes and on the view did load, it goes and calls the service to get all the contacts. It creates a UI table view source, which is needed by the table to manage the list, and you pass in the data that you get from the service. So you say table view.source, and you set that with your custom UI table view source, which is this one. So this is a derived class called contacts table source. So this takes care of, it has like overrides for rows in section, for like getting the cell and also getting the contact. Now, when you click on a cell within the table view, it's gonna invoke prepare for segue, and this is where that segue that I showed you on the storyboard, it will be invoked, and it will navigate to the details screen for the contact. Right. So that's for iOS. In Android, I'm gonna show real quick here the designer. So the layouts, so Android screens are created using layouts, and they are under resources. There's a layout folder. So the main layout is, this is actually have a list view here. When I select that, that's a list view. If you go to the source, it's just XML. So as you can see, there's a list view here with some properties that I have set already here. Now, when you go, each of the rows in the list view is actually defined with a custom layout, and that layout is called list item row. So if you look at list item row, it has an image, it has a text view for the name, and then a text view for the email address. And then once you click on a row, it will now go to a detail screen, which is, again, it's a separate screen, a separate layout, and it has an image, it has a name and an email placeholder, so that when you pass in that data, it can be able to render that information on the screen. Okay, so that's the Android designer. Let me go and run the iOS app real quick. Build. I'm going to rebuild this one just to make sure. Let's check if we miss anything and have compile errors. Oh, there you go. So here we just need to set up the configuration manager to set up the make sure that we build, when the solution platform is iPhone Simulator, for example, we also want to build the core, which is the PCL. build. All right, so it succeeded. Let's go run this. Let me find my simulator here first. There we go. Put this aside here real quick, and then run. So now it's going to go and hit that Azure Web Service to get all that data. It's going to go render the list of contacts and also allow you to go navigate still to the detail page. So that works. Same thing with the Android version. We just have to set this as a startup project and make use of the Android player that is provided by Xamarin. Let me just run this thing real quick here. Okay, so it's building right now. All right, so it looks like it's working, and we're able to go navigate to the detail screen, and also take a go and scroll through the list of contacts. Okay, so what we did here, just to summarize, is that we have refactored two projects that are not doing any code sharing, and now there's some code sharing that is involved here. So in this case, for this is what you call the classic Xamarin, where you're using Xamarin.Android, Xamarin.iOS, and you are using PCL as a way to go and do code reuse. So the way you are going to be sharing code here is mostly your app logic, the business logic. So in this case, the logic of retrieving the information you need from a web service is something that you can be able to reuse across the two platforms. And for example, let's say you have some calculation that you need to perform. Those are the things that are not platform specific. They are not tied to the UI, and those are the things you can be able to move to the PCL project. Obviously, you're still gonna have a lot of UI and platform specific UI code that are platform specific. That is something that you cannot be able to avoid using Xamarin Classic. You can be able to maximize your code reuse more if you, for example, if you go and let's say use another framework, an MVVM framework. MVVM stands for Model View View Model, which is a pattern for driving the UI and separating concerns in your application. So if you make use of an MVVM framework such as MVVM Cross or MVVM Lite, you can maximize more of your code reuse using classic Xamarin. You probably will be able to see that we did not discuss Xamarin Forms at all, and that's because Xamarin Forms will be discussed on a later webinar where we will be focusing on Xamarin Forms. But for this one, Xamarin Classic is what we have presented, and what we have shown you is a way to go and share code across multiple platforms. Talking with my experience with developing apps and leading teams in mobile applications, Xamarin Classic is still one of our top choices for implementing mobile solutions. The reason is because it has the best performance. You're close to the metal in terms of the APIs that are available for iOS and Android. So definitely you would need to, whenever you're tackling a new mobile project, you want to evaluate first whether Xamarin Forms or Xamarin Classic is going to fit the bill. Okay, so that is for the demo. We'll switch back to the presentation. Let me just bring it up real quick here.
Awesome job, Jon. And so, yeah, thanks for that demo. Jon just showed the Xamarin platform, but as some of you may know, and as you'll come to realize, Xamarin is much more than just our platform. That's been sort of our bread and butter for the past decade. We've been working on the technology. For those of you that are familiar with the Mono project, that's where the Xamarin platform comes from. We've been around as a company, though, for the past 3-4 years. And so after you develop your mobile application, you're going to need to test your application, and then once you launch your application, you're going to want to run insights into that application. And so with Xamarin Test Cloud, that's another product of ours, you're able to test your application across 1,200 physical devices that are in our device lab in Denmark right now. And then finally, once you end up launching your mobile application to the Google Play Store or the Apple App Store or Windows Store, you're able to run Xamarin Insights into those applications to get analytics into how your users are engaging with your application, or retrace steps that come to errors in those applications. So then you can go back into the platform, fix those bugs, retest it in Xamarin Test Cloud, rerun it in Xamarin Insights. So we're with you the entire application lifecycle during your entire mobile project. With that, I wanted to actually take another quick poll as to what you guys want to hear from us next. We have a few options here, and I think Kristen's going to, put out that poll again for you guys to select what you guys want to hear from in our next webinar. Automated testing across multiple devices, building cross-platform UIs, cloud services, real-time app monitoring, or anything else that you guys had in mind. And then once that's done, we'll take a look at those, but wanted to also open it up for a quick Q&A session. I believe we have 15 minutes left.
Yeah, so while everybody's having a chance to complete that poll there, we'll keep that up for a few minutes, but we've had some great questions come in along the way. So please continue to ask them in the questions panel there. But in the meantime, our first question was asked a little bit earlier on, but it was, does Xamarin Studio integrate directly with Team Foundation Server?
Xamarin Studio, no, it doesn't. What you will use to integrate with TFS or Team Foundation Server is a Visual Studio. But it shouldn't be a problem if, since you can be able to do all your development on a Windows box using Visual Studio. You just need a Mac that is in the network if you are going to go do compilation for your iOS application.
And so another question we had was, so in order to deploy multiple platforms, do we still need to use multiple projects, one for each platform for which we wish to deploy?
Yes. So if you need to support, for example, if your application will be deployed to as an Android application, as a iOS, as a Windows Windows Phone application, or even Windows Store, you need to have those platform-specific projects in your solution. Because again, with classic Xamarin, and this is applicable also to Xamarin Forms, right? You still need those projects because it uses the native UI on those platforms, so it uses all the native APIs, and therefore you have to have those projects included in your solution.
And actually, there's something really great that came up here that I think we actually missed in the beginning. So anybody who attended today's webinar, or if you have a colleague who maybe wasn't able to attend, we will be sending the presentation, a recording of today's presentation, out afterwards, and we'll also be sending out the slide deck as well. But another question that came in here is, how do we tie in with platform-specific functionality like Research Kit, Health Kit, or Map Kit?
Right. So those are available. Those are available on the iOS project, right? So because there are just, as Zach mentioned earlier, Xamarin exposes 100% of the API for iOS and also for Android. Now, typically the way you would want to go and tackle that from a design standpoint is to go define interfaces. So a good example of this is, let's say you want to do content sharing. Let's say you want to go share a page or share a contact. You can go and create an interface. Let's say iShareable or something. You put that on the PCL, and then using dependency injection, like you can make use of, for example, tiny IOC as your IOC container, and then from there, when your iOS application runs, you can be able to specify the concrete class that implements that interface, and that concrete class will live in your iOS project that goes and make use of those APIs, those platform-specific features. So, but at the same time, you have an interface that is in the PCL that is something that, for example, shields you away from, gives you better code reuse and better, I would say, structure. So you could also have the same. You could have also an equivalent implementation on the Android side or on the Windows phone side, but it's making use of that interface using dependency injection.
And so, Zach, I think we have a question here that's probably good for you. Someone has asked, is Xamarin Test Cloud and Xamarin Insights, are they included in the enterprise pricing, or are they separate products?
So right now, Xamarin Test Cloud is a separate product. Xamarin Insights is still in beta, so it is included in the Xamarin Enterprise. You can start using Xamarin Insights today. Xamarin Insights will be a standalone product, but that'll be in the coming months. We will always have a free version of Xamarin Insights. One thing that I should note about Xamarin Test Cloud, which I didn't, it's very cool because you can actually test any application in Xamarin Test Cloud. It doesn't have to be a Xamarin specific developed application. You can test siloed native applications, you can test hybrid applications and Xamarin applications as well. For Xamarin Insights, it needs to be a Xamarin developed application at this point. But yeah, hopefully that answers your question.
And then another question here is there going to be a Xamarin Mac trial?
That is a good question. So Xamarin Mac, you're right, is a separate product. We're pretty much Xamarin iOS, Xamarin Android, and Xamarin.Mac. If you wanted to play around with Xamarin Mac, you could reach out to me afterwards and we could coordinate how to set up a trial.
And so we have a few more minutes for questions here. Another question that's come in is there a way to use dictation voice in iOS using Xamarin?
Dictation voice, like if it's available as part of the iOS API SDK API, it should be available because the way things work in Xamarin is that every time there is an update to the, for example, iOS 8.2 or whatever version is going to come out, within a day or two, Xamarin has already generated the .NET bindings, the C# bindings for those new APIs or change APIs. So therefore, everything that is accessible via the iOS SDK, you can also be able to access that in Xamarin and make use of it.
Okay. So using the PCL choice, how would we connect to services over HTTPS?
There are several ways to do that. There are some issues with regards to certificates. It's the same thing. You make use of HTTP client. There is also some other third-party libraries out there that probably does a better job. Modern HTTP, that is developed by Paul Betts. It's called Modern HTTP. You may want to take a look at that one as a library you want to use to connect to SSL-enabled services.
Okay, and as we give people a few more minutes, a chance to see if there's any other questions out there, I think if we go to the next slide, we have one more poll that we'd like to ask everybody. So before we launch the poll here, we'd like to find out if you'd like a deeper dive or a continued discussion. Please feel free to go ahead and respond to this poll here. And in a minute, we'll flip back to the slide where you can quickly jot down the URL where you can actually get the code that Jon showed today. If you don't have quick fingers, that's no problem. We'll also be sending that out to you via email afterwards. But as we give everybody a chance to answer this last poll here, we've had another question come in. So, must an app be deployed to the App Store for it to be installed outside of the App Store?
If I trying to understand the question, so let's say I think what he's asking is if you want to go and be able to deploy that an application that is still in beta, or you just want to go test that to beta testers inside or outside of your company. There are third-party services such as TestFlight, which is by Apple. You can be able to use that to go and beta test your app without necessarily publishing it to the App Store. There's also Hockey App. Hockey App it was just recently purchased by Microsoft, and it supports all three platforms, Android, iOS, and Windows Phone, where you can go and deploy binary. You can be able to go distribute binaries of your application into Hockey App, and then you can be able to invite beta testers to go and download and install beta builds of your app without necessarily having to go publish them to the appropriate app stores.
And so the asker of this question just clarified here, they were referring to an enterprise application that might not be required for the public. So I think
yeah, so, gotcha. So it's not a public app store. So you can obviously make use of an enterprise app store like that comes with some third-party services, part of your MDM. There are several out there that you can use that you can be able to use as your enterprise app store. And then again, what I just mentioned about TestFlight and Hockey App, you can also use that for testing and development.
Great, thanks, Jon. So if there's any other questions out there, please feel free to answer them ask them in the questions window there. We'll go ahead and close this last poll here, and then we'll go ahead and give everybody a chance to get down the URL where you can go and get the code there. So if you jot that down, never fear if you're not quick enough, we'll pop that out via email afterwards as well. And I don't see any other questions coming in. So with that, we'll go ahead and wrap up today's presentation a few minutes early. So thank you everybody for joining us, and thank you Jon and Zack for guiding a very insightful discussion this morning. Thank you everybody.